Welcome. Today is Engineering Mechanics class number 77, part 2. Today's class is lecture 36. Now, make a note. Actually, there is a problem for recording. Heavy rain going on here. Somehow I managed to get some time, line reduced. So, today's class will be a little short class. But I want to cover important concept now. See. You make it, those who are serious write everything. In the previous class, that is Engineering Mechanics class 76, part 2, lecture 35, in question 3, see again, rain started now. In question 3, we considered a simply supported beam AB of span L, somewhere here C I will tell, a point load W at A from here, B from here, span L. This is also called as eccentric. You can call this one. There is no place right here. This question 3 is simply supported beam with eccentric concentrated load. Simply supported beam with eccentric concentrated load. Eccentric means anywhere. Let the load be W, let it be at A from left end, B from right end. Okay, little dark I will write. W, this is A, this is B, span is L. I told you A plus B equal to L. Suppose this B is not there, you write L minus A. Suppose span is 10 meter, this is 4 meter. That becomes 6 meter. That is okay, no problem. Now, we want to find vertical reaction. What I have done last time, take moment about A minus VB into L plus W into A, this all thoroughly covered. A plus W into A equal to 0, VB you got WA by L. Sigma V0 plus VA plus VB minus W equal to 0, substitute VB equal WA by L, we got VA WB by L. This over. Then I told you, now once again explanation for vertical reaction for a simply supported beam subjected to a concentrated load anywhere between the supports. Remember, now anywhere between supports, very important, it will be between supports, and also no other loads and no couples, very important, no couples, neither inside, neither at ends nor somewhere in the beam, somewhere inside. Okay, right here. That is no couple here, no couple here, no couple here, nothing. Or remember, only one load, only a concentrated load, no couples, and also both ends are vertical reactions considered. We are considering only vertical reaction. Horizontal reaction, we are not bothered. Remember once again, only load, couples are not allowed. Overhang is not possible. Suppose there is a overhang is there. If a load is applied there, that you can't apply. The load should be somewhere in between, anywhere between supports. Now see, this reaction W into B by L, this reaction W into A by L, or I told words for both reaction common, whether you want left or right reaction, load, if I want reaction here, see, load into other distance, other. From the load, distance to others, you write here, other distance means from the load to distance to other support. Remember, this reaction VA equal to load into other B divided by L. Or if I want VB equal to load into other A divided by L. This is very thoroughly explained. Also in the class, you cannot apply this one for a propped cantilever or fixed beam or continuous beam because there are end couples are there. You should consider only vertical reaction due to a point load both ends simply supported. If couples are there, we will tell, see what to do later. Okay, now, this is what you have done. Make a note. Sufficient now. Now, make one more note. Usual problem. Usually after rubbing, I throw it outside. Okay. Now, all I will remove now. Everything remove. I will tell you the purpose. See, it again slowly started raining now. Somehow, I will complete this question now. Okay. So, it's a small class today. This is also over. Now write a note. Very important note. In class number, in engineering mechanics, I noted down there because to avoid confusion. In engineering mechanics, class number previous to last class is class number, where I wrote it, 75 is class number 75, and part 2, lecture number 34, right here, you write here, we considered this question. A beam of span 12.5 meter loaded by a point load of 50 kilonewton at 3 meters from, you can write once again, 3 meters from left end, another point load of 60 kilonewton, 2 meters from right end, UDL of 20 kN per meter, 5 meter long, starting at 4.5 meter from left end. Then this gap will come 1 meter. We found reaction, see. Right. Then in that class, we found reactions. We found reactions systematically. What I am telling is shortcut, systematically as given here. Once again I will explain, not explain, I will read here. Take moment about A. This is explained many times. Go back to that class. Minus VB into 12.5 plus 50 into 3 plus 20 into 5 is the total load into 4.5 plus half of 5 plus 60 into 10.5 equal to 0. We got VB 118.4. I noted down. Sigma V0, VA plus VB minus 50 minus 60 minus 20 into 5 equal to 0. We got VA. Write this much. Now write one statement. You write all these. Okay. Once you write all these, you write. Now, question. Can we apply that shortcut of what? Any reaction equal to, just now I told, load into other distance divided by span. Can you apply for this one? Someone will tell, no, you can't apply. Why? Because you told there only point load is there. One point load. But here there are 2 point loads and a UDL. Still you can apply. My purpose is to make every concept clear. But make a note, for this question, this only is better. Someone will be laughing. If I do that way, they will tell, sir, so simple here. You are making complication. Yes, my purpose is not to make complication. What principle I told, I will explain that one here. So, right here, we can apply, but remember, you have to consider each load separately. Once you have all the statement you write, once you consider only 50 kilonewton, then consider only 60 kilonewton, then consider not UDL. For this UDL, you consider the total load through the line of action. Line of action is center of the UDL. Then for each load separately apply this principle. Any reaction equal to load into other divided by span. Then add all the values. That is called superposition. So for each load, find the reactions, add it. See, but actually someone will tell, this is much better. Why you are doing all these things? Only concept purpose. Remember, only to understand the concept. Okay, now start. I think it rained heavy, more severely now. I will just pause for a little time. I don't know, whenever I start class, start raining. Okay. When it was raining, I wrote this much. Okay, now, right here, we can apply. Right, how to apply? Right here. I told already, consider each load separately. So what I will do is, I will consider which load? 50 kilonewton at C. See here now, 50 kilonewton here. This is 3 meter. If this is 3 meter, from here, 12.5 minus 3 is 9.5 meter. Okay. Span is 12.5 meter. Then consider UDL from which point? D to E. D to E. See here. Light line, right? This is D, this is E. Now, if you want to use a red color here to understand, see, red color. Okay, now, it is, see there, 20 kilonewton per meter for 5 meter. You don't write here. 20, you can refer that sketch only. Don't write anything here. 20 kN per 20, see this is 50 kilonewton load. 20 kilonewton per meter for 5 meter is 20 into 5 kilonewton total load. How much is not required? Now, line of action will be exactly through, you write there, center of the UDL. That is from here 5 by 2, from here 5 by 2. Therefore, distance from here will be, see here, 3 plus 1.5, 4.5 plus another half of 5 will give you 7 meter. From there, once it is 7 meter, total 12.5, it is 5.5, or anyway check it. 2 plus 3, 2 plus 1, 3 plus another half of 5. Okay. Lastly, consider only 60 kilonewton. See here. At which point? I will write here now. Consider which load? 60 kilonewton at F. F. See here. From there 2 meter, from total 12.5, this is 10.5 meter. Okay. Now, we get 3 separate cases of just 1 point load. So, this reaction is, see, 50 into 9.5 by 12.5. And this reaction, 50 into 3 divided by 12.5. I will calculate that one. Honestly with you, I have not calculated. Why? Because I know answer will come. 50 into 9.5 divided by 12.5 will come 38 kilonewton. 38 kilonewton. I will round off. This will come 50 into 3 divided by 12.5. 12 kilonewton. I will round off that answer. 12 kilonewton. Here, see, total load is acting here. This reaction is, this 20 into 5 is the total load. See, when you write 20 kN per meter, it is not load. 20 kN per meter for 5 meter is load into other 5.5 by 12.5. Already written here, 12.5. 20 into 5.5 by 12.5. 100 into 5.5 divided by 12.5. 44 kilonewton. It is 44 kilonewton. That reaction, 20 into 5 is the load into other distance is 7 divided by 12.5. 100 into 7 divided by 12.5. 56 kilonewton. 56 kilonewton. Okay, now, lastly here, this reaction, 60 into 2 divided by 12.5. 9.6 kilonewton. There, 60 into 10.5 divided by 12.5. 50.4 kilonewton. You write all these separately. Now write last answer. Therefore, right here. Therefore, superimpose all of them. The final reaction at A, final reaction at B, or actual or final reaction, reactions at A and B at A and B, considering entire loading, will be algebraic sum, you can write here, equal to R reaction will be, I write here will be, you can make a note here in the bracket, which is given by algebraic sum of all the values. Now algebraic sum is not required, all are upward, so plus minus not required. So final VA, your final VA in the upward direction equal to, see here, 38 plus 44 plus 9.6. I need not calculate. I am so sure it will come plus 91.6 kilonewton. I will check later. Okay. And final VB in upward direction equal to 12 plus 56 plus 50.4 equal to surely plus 118.4 kilonewton. Right here. Oh, same as what you got earlier. Still not checked. Okay. 38 plus 46 plus 9.6. 93 38 plus 44 plus 9.6. 91.6 kilonewton. 12 plus 56 plus 50.4. 118.4 kilonewton. Now make a note. Now you remember what is the use of doing this way. Someone will tell, sir, who want all these? When easily you will get yes. You apply this principle not for this such of beams. For such type of beams, it is a waste of time. You apply directly, you write here for this question, what we have done in that class. It is class number, engineering mechanics class number 74, if I remember, and lecture number 33, what I told, that is correct. Do that way only. Don't try this one. Then why all this? This is to give you more grip, because later see, so many times you require reaction for loading all. Suppose a question this way comes. You don't have to struggle, take moment about A minus VB all you require is load into other by span, load into other by span, or see this type of load. 2/3, 1/3, this reaction. Load into other by span, this reaction. Load into other by span. Because this is a very important principle. That's why you make a note here. This is only for understanding purpose. No, never try this way. See, that is so easier. So later, combination of loads, we will not try this one. We will try it for individual cases. So many times, individual cases, it becomes, you are wasting time writing every time sigma m about A0 minus VB into something, etc., etc. Directly take calculator, enter the answer. So as we go further, for all individual cases, as we get the answer here systematically left side, right side, I will check this answer by this principle. It will tally. Okay, now condition is there. See, only vertical reactions considered and vertical load for a horizontal beam. Only load. There should be no couple. See, you cannot apply this for couples. Couple neither in the span nor at the support. You can apply for vertical beam also. Load should be horizontal. Then you get horizontal reaction. That comes in the frame. I will tell when you go to frame in structural analysis. Okay, now rain stopped, but anytime it may come. So I will do one thing now. Instead of writing something and waiting for hours together, sometime I had to wait for more than half an hour trying to stop. So I think this concept will cover everything. Next time I will go for question number 4, and marathon we will solve one by one question. I will not explain this principle again and again. I will simply tell, if you are serious, you should have gone through earlier. Otherwise, you know what I tell otherwise. Not serious means my class is not suitable for you. Okay. Thank you.